now that we've learned all of our methods and kind of mixed them all together, as far as solving quadratics go, we're going to go ahead and do some applications now for the next couple days. So projectile motion problems today. Projectile is any object that is thrown, shot, or dropped. The given formula is used to determine the object's height at any given time between t equals 0 when the object hits the ground, when the height is measured in feet. Okay, so it's important that you notice that's measured in feet. If we change to meters, that's going to change this a little bit. So in this problem, h of t is the height at any given time. So this is your height. Your t's stand for time. So if we were to graph these, h of t is on the left side, time is on the bottom, and then two pieces of information that you'll also be given that will be numbers that get plugged in is v naught and h naught. Okay, we call those v naught, h naught, v sub 0, h sub 0. That is the starting velocity or initial velocity and the starting height or initial height. So those are important pieces of information. You do not have to have this formula memorized for your test, but you will use it. Okay. One thing you need to remember is if I'm looking at the graph, that x-axis is actually like the ground. Okay. So let's go ahead and solve this. First problem. Formula is up there. We don't actually need it. It's plugged in for you already. But a frog jumps straight up from the ground. The quadratic function h of t equals negative 16t squared plus 12t models the frog's height in feet above the ground after t seconds. What is the frog's maximum height and how long does it take to get there? Now, if you think back to the first part of this unit, the part that you already took a test on, maximum height has to do with the vertex. And to find the vertex, we did the opposite of b over 2a and then plugged it in. Okay? So we're going to go ahead and do that. We're going to do the opposite of b, so the opposite of 12 is negative 12, over 2 times a, and a is negative 16, and we're going to simplify that. And type that in our calculator, actually, and our answer is 0.375. So that is our x value for our vertex. The y value we need to find by plugging that back in. So negative 16 times 0.375 squared plus 12 times 0.375. And we're going to plug that in our calculator to see what we get for an answer. And we actually get 2.25. So our maximum is the point 0.375, comma 2.25. Now, if you think back to this graph here, diagram, this is my height, and that's my y. This is my time, and that's my x. So x is time, y is height. So to answer the question, what is the frog's maximum height and how long does it take to get there? Well, the max height is 2.25 feet, and that is at 0.375 seconds. This is your final answer for that problem. First part of that problem. Okay? The second part asks you to see how long it takes, or how long the frog is in the air, or how long it takes before it hits the ground again. Now to do that, you need to think about this. This here is my height. Well, if I'm on the ground, my height is 0. So all I'm going to do is set that equation equal to 0 and solve it. Now, first step is always check for GCF. Makes it easier. I can divide both of those by a negative 4 or a positive 4. And they both have a t there. And then I'm going to go ahead and divide that out. So 16 divided by negative 4 is 4. And I took out a t, so I have a t left. And then 12 divided by negative 4 is negative 3. And then think back to 2.6. And solving by factoring, we're going to do negative 4t equals 0. And 4t minus 3 equals 0. So for the first one, our time is 0. And for the second one, and we can use decimals here. I know I told you no decimals before. We have 0.75. Okay? So we know that the frog is either in the air for 0 seconds or 0.75 seconds. Well, if you think about a graph, starts on the ground at 0, jumps up in the air, comes back down to the ground. So yes, it's on the ground at 0, but that's the starting. So it takes 0.75 seconds for that frog to hit the ground again. Okay? So anytime you see maximum, think vertex, and anytime you see how long does it take before it hits the ground, set it equal to 0. Okay? Let's do one more, and then there's one for you to try. Okay, so again, part 1, a baseball is thrown with a vertical velocity of 48 feet per second. Hang on, let's get our highlighter out here. So this here is pretty important. Okay, vertical velocity, that won't scribble any of that in. Okay, of 48 feet per second, that's going to go for vertical velocity there, or initial velocity. Then the initial height of 5 feet is going to go in to this one right here. Okay, so let's start by setting that up. So I have h of t equals negative 16 t squared plus vertical velocity, initial velocity is 48t, and starting height is 5 feet. Okay, so there's my function. So the next part tells you to write the function to model h in feet where t is time in seconds since the ball was thrown. Okay, find the maximum height the ball reaches and approximately how long it takes to get there, and run to the nearest hundredth. So, like I said, maximum height you need to think vertex, so we're going to do the opposite of b over 2a. So if I do that, the opposite of 48 over 2 times negative 16, and simplify, and we get 1.5. And then go and plug that in. Negative 16 times 1.5 squared plus 48 times 1.5. Sorry, you can't read that. Fix it. Okay, so 48 times 1.5 plus 5. Type all of that in your calculator, see what you get. You should get a 41. Okay, so what we just found is our time is 1.5 seconds, our height is 41 feet. So the maximum height of 41 feet happens at 1.5 seconds. And that is your final answer. I'm actually going to take this equation with me because we're going to use it. So I'm going to copy that. The second part of this problem, bottom of the page, asks to find how many seconds it takes the ball to hit the ground. Okay, there's our equation that we wrote on the previous slide. So to figure out how long it takes before it hits the ground, we're going to set that equal to 0. And I don't care if you put the 0 first or second. A lot of you prefer that's on the right side, so let's go ahead and do that. Now, I don't know about you. I'm not sure about factoring that one. So I'm going to go ahead and do the discriminant. So b squared minus 4 times a times c. I'm going to type that all in my calculator. And when I do that, I get a fairly large number, so 2624. And since it's such a big number, and those are big numbers to factor, I'm going to go ahead and take the square root of 2624 to see what I get. And I actually get a decimal. And we can use decimals here because it's an application problem. Can't use them if it's not an application problem. So I'm going to go ahead and do the quadratic formula. So the opposite of b, which is negative 48, plus or minus whatever we got in that last step. Wrote that backwards. 51.225 over 2 times a, so 2 times negative 16. And we're going to simplify a little bit. And then when I split it into 2 parts, and type it in my calculator, I get a decimal for the first one. I get negative 0.1, but it's negative. For the second one, when I type this in the calculator, I do get a positive decimal, which is 3.1. Okay? Eliminate that because we can't have negative time, so how long does it take for it to reach the ground? It takes 3.1 seconds. And that's your final answer. Try the last problem there. You only have like 3 problems in your homework. They're all very similar. If you have questions, make sure you talk to a partner, ask a teacher, and then go on from there. Have a great day.